Everybody, so as promised, I am coming to you today from my kitchen. I'm going to show you some convection currents. So I'm using water, but I want you to understand that the water is representing air masses, so different types of air masses. So what I have here is just a simple bowl of water. Hopefully you guys can see that. So here is my bowl of water, and I'm just kind of waiting for it to settle. The water is kind of warmish, but not too warm. So I'm going to put that there. Then what we're going to have here is I made some giant ice cubes. I apologize. I need a paper towel real quick. So I made some giant ice cubes, and I'm going to, as carefully as I possibly can, because it's obviously ice cubes are slippery, I'm going to put it into the water. Try not to disturb the water too terribly much. And what we're going to see here is going to happen is that current is going to immediately start. I'm going to take and let this ice cube go where it wants to go. And then on the opposite side of the ice cube, I'm going to drop one drop of, maybe two, of food coloring, so red food coloring. So the red represents a warm air mass and the blue represents a cold air mass. So what we're going to see here is that these two air masses are going to mingle together, okay? So you can kind of see that they're going around and these two air masses are going to go. So what's happening here is that a warm air is forced up by approaching cold fronts, and then it creates an updraft. So those updrafts of warm, moist air. And what happens is then during these cold fronts, it builds a cumulus cloud from that front coming in and making that updraft. It also makes thunderstorms. So when these thunderstorms happen, warm air rises, it condenses, and it fuels this thunderstorm. So I'm going to show you guys really quickly from the top so you can see this. I won't probably talk during this time because it's kind of hard to hear me when I do this, but it looks a lot different from the top. So I'm going to show you. So as you can see, I'm not moving the water, the ice cube, or any of that. It's just happening on its own as it does in the air. So these are just moving around, creating that convection current. So remember how we talked about convection currents in the mantle, how that goes around and that's what makes the plates move? Well, it's basically the same thing here as these convection currents move around and they change the weather. So they force air masses to move. And when those air masses move, it makes different types of weather. So as you learned yesterday, when we talked about air masses, we have continental, which means land, and maritime, which means over like ocean. So continental is dry and maritime is moist. So it can either be polar or tropical, so either closer to the equator or at one of the poles. So if it's polar, we know that's going to be a colder air mass. If it's at the equator, that's going to be a warm air mass. Depending on if it's over land or sea will determine if it's going to be warm or moist air. So I'm going to give you one more shot of this because it's really kind of mixed together. So that convection current is really working now. So I'm going to show you guys one more shot of this and then explain your assignment for today. So as you can see, the ice cube's still spinning and it's spinning on its own. I haven't touched it. It's just specifically spinning because of the fact that that current is moving through there. So remember that, again, how air is working. So your assignment for today is obviously to watch this video, and then you're going to write down 3 things you learned, 2 questions you still have, and then find a picture of a convection current online. Make sure it's appropriate, please. You guys did a really great job finding some weather pictures. This is the other video that I shared with you yesterday, answering some questions about hail. I was really impressed with some of your pictures. They were really cool to look at. My family are big weather chaser people. They love to look at different weather and things like that. So they really enjoyed those as well. So hopefully you guys find some cool convection current pictures out there too. If you want to watch other videos and let me know what you learned off of those, if you feel like you didn't learn enough off of this one, I'm basically just explaining to you how exactly a convection current works. that if you find something else out there and you learn that from there, you can go ahead and note that on your 3, 2, 1. I'm going to quick show you one more time because this kind of made a cool swirl here. So I want you to be able to see that. So I'm going to show you one more time from the top and then we will be done. Good luck on your assignment for today. If you have any questions, you for sure can email me or your science teacher with those questions, and we would be more than happy to answer them for you. Really quick, one more time. Hopefully you guys can see this. Apologize, I'm a little shaky, but you can see that this is coming around and swirling like that. So that's pretty cool to look at that way. All right, you guys have a wonderful day, and hopefully I will see you soon, or at least you'll see me on video again.